Good evening, everyone. My name is Sam. I'm working on a project called Vectorly, and today I want to talk about vector graphics and its potential for delivering mathematically perfect quality video at ultra-low bit rates using open and existing standards. This is a bit of a niche topic, so I'll quickly go over what vector graphics is and review some of the standards for rendering vector graphics on the web. Then I'll introduce a couple of projects and companies that use vector graphics video and discuss some of the advantages of vector graphics video, as well as some of the barriers that have kept it from being used more widely. Finally, I want to talk about some experiments and projects we've worked on that we think can make vector graphics a more viable option for delivering video on the web. Starting out with what vector graphics is, most video in the world is made of pixels, and video compression is all about using fewer bits of data to recreate all the pixels you see on the screen. Vector graphics is a bit different. Here the idea is to send the instructions to render an image to the user's device. Those instructions come in the form of usually math functions to draw curves, shapes, colors, and other graphical elements, and the user's device is then responsible for actually rendering that image and displaying it on the user's screen. This is not a new concept. There's some well-established standards for rendering vector graphics on the web. SVG is probably the most well-known. It's an XML-based graphics language, and you can use XML syntax to define things like rectangles, circle, text, arbitrary shapes. And anytime you have properly formatted SVG code, as long as you stick that into an SVG parser, which includes most modern web browsers, it will then render the corresponding SVG image. Canvas is a bit newer. It became popular with HTML5, and while SVG is a programming language, Canvas is actually an API that's exposed by web browsers. You can use it to draw the same exact things like circles, shapes, text, and whatnot, but because it's a drawing API, it's most commonly used for rendering dynamic content like web games, whereas SVG is more often used for static content like static images, banners, logos, that kind of thing. WebGL is by far the most obscure of the three. Like Canvas, it's a drawing API, but the key difference here is that WebGL leverages hardware acceleration and renders directly to the GPU. It is a bit more complicated, as you can see from the Hello World example here, but the counterside is it is much more powerful and can enable native level rendering performance. So, although these Hello World examples were pretty simple, these web technologies are capable of rendering pretty complex graphics on the web, including complex 3D animations in video games. And the thing to keep in mind is that none of this stuff is bleeding edge or nightly build stuff. SVG and Canvas are better supported than the HTML5 video tag. The point is that these are pretty well established standards. And there are a couple of companies using vector graphics in video. Perhaps the most famous and well-known is Adobe. So if you ever use their Animate or After Effects software, you can export those animations to Canvas or WebGL or some of their proprietary runtimes. Here's an example of a Canvas video from Adobe. I put a nice little video wrapper around it so you can kind of see the comparison with the H.264 version. It renders pretty nicely on a 4K screen, and you can also see the bitrate difference here. It's pretty sizable. Lottie is essentially an open source extension of Adobe, so if you have Adobe files, Lottie will let you sort of convert those files to JSON, and they also have players on Android and iOS so that you can play back Lottie files across platforms, web and mobile. One of my favorite projects is Scrimba. They create interactive coding tutorials. So, there's a lot of coding websites. You can see tutorials on how to do programming. But unlike most sort of coding video tutorials, this isn't actual video. This is interactive HTML that's synced with a video file. So you can actually type in the text box like const I don't know, like you can basically interact with the document, with the screen, which is pretty interesting, honestly, and has all the benefits of vector graphics video. These videos are super light. And finally, our company, Vectorly, is working on a raster to vector transcoder. So the idea is to take in an MP4 file and convert it, transcode it to SVG and WebGL. The hello world for our company is essentially like this 720p clip of The Simpsons that we just kind of scraped from YouTube, and you can see the vector output here. It's the nice thing is it is vector graphics, so you can actually kind of click on the elements and see the vectors as they change over time. There are some artifacts, as you can see, but this is kind of our first pass, and so for a first pass, we think it's reasonable enough. And of course, we're working on improving it, and we hope to make raster to vector a viable transcoding option in the future. That begs the question of why anyone would care about vector graphics video, and the answer is pretty simple. This is it. Vector graphics, especially if you have source files, say like an Adobe source file, you can get stupid low bit rates for perfect quality. So imagine like pixel perfect 8K video at 50 kbps. It's really hard to imagine raster graphics codecs like AV1 ever coming close to that level of efficiency. The main gotcha, of course, is that you need vector source files which aren't just floating around. Even if you do transcode from raster to vector, though, there is some artifacts, certainly, but you can get pretty good results, and much better than you can get with raster codecs like H.265. The other sort of benefits rather, are that you no longer need multiple bitrate versions, multiple presets of the same video. Because one vector file can play at multiple resolutions, you only need one vector file and one audio file, and that vector file will play back at any resolution that you want it to play back, and whatever resolution is supported by the end user's device, which is nice to have. We obviously went over animations and screen sharing e-learning, so those are a couple of examples of where vector graphics could be used, but there's a couple others. You can imagine esports. Certainly libraries like WebGL are more than capable of rendering simpler video games like Minecraft and Fortnite. So there's certainly potential for using vector graphics to deliver that kind of content. And you can also imagine computer graphics overlays. So if you imagine news tickers or sports scoreboards, that kind of content is hard to handle from modern normal encoders, but for vector graphics, that's kind of the bread and butter for vector graphics. And so you can imagine a lot of value from taking a hybrid approach with vector graphics for the computer graphics overlays and normal encoders for the live streams. Now, there's a reason why people don't use vector graphics as much right now, and probably the biggest certainly is that there's very limited use cases for it. Outside of the ones I just mentioned, you can imagine that if you only have like 5 or 10% of your video, having majority vector graphics content, it doesn't really make sense to use such a specialized codec for such a small amount of your video. You also need the vector source files, which, if you have them, great. This should be an option you should consider, but otherwise it's pretty difficult. Though, of course, we're trying to make raster to vector a viable option. Finally, vector graphics doesn't just fit into modern video infrastructure, but I do want to push back on this idea. We have done some experiments to show that you can actually integrate vector graphics into modern streaming formats like HLS and Dash, and even play them back in things like Video.js. So here's an early proof of concept that we did. So we took a vector graphics based video. This was one that we recorded a long time ago. It was sort of an edtech video, and if you open it up and play it back, it looks like there's a video here, but actually most of the content is being rendered in SVG. You can see the SVG located somewhere around here. You'll see all the cool SVG stuff. And then when you actually play the video, it looks and feels like a video. But there, you can see the Dash fragments loading over time. And so this is a vector video, which is just SVG packaged into a zip file and packaged then into an MP4 file that we fragmented in MP4 box and then streamed over Dash. And the idea you can do that with a video is sort of indicative of like the possibilities. Like if you could do this with Dash and have it play back in Dash.js, you could easily imagine this done with HLS and other modern video web players. At the same time, we've also seen that you can use the Media Streams API to render vector graphics content directly into the video tag. So the same exact content that you saw before, the Adobe tutorial, here's that same video being rendered directly into a video tag. So this is actually a video tag, and with the Media Streams API, you can then treat this vector graphics as any other video stream, and that lets you kind of mix and match with alternate video streams, play back with play well with MSC, and have it work with sort of adaptive bitrate logic, and that really opens the door to then making this work well within the rest of HTML video and modern video architectures. So I think maybe the main kind of food for thought that I want to leave for the SF video tech community is, vector videos can be transcoded. They can be packaged into MP4 containers and streamed over HLS and Dash, and they can be rendered into a video element. So the question then becomes, why not consider them as video codecs if they look like video codecs, if they feel like video codecs? If you can treat them like video codecs, why not consider them as video codecs? Like I mentioned, there's a couple of reasons you might want to. There's certain kinds of content for which vector graphics has an advantage, bit rates, interactivity. There's a couple of advantages of why you might want to consider them as codecs. Going on that note, one of the open source projects that we are working on is an encoder and packager to do just that. So if you have vector source files like Flash files or Lottie files, we're working on a transcoder that will then take those files, kind of package them into an MP4 container and package that as like a vector track within Dash or HLS. And on the other side of things, having plugins for modern, video players like Video.js or JW Player or whatnot to then kind of detect that vector track and play it back within the ABR logic of the player. And using that, I think you could make vector graphics a much more viable option for delivering video on the web. Kind of wrapping up the talk, if you want to explore vector graphics more in detail, here's a couple of resources. Obviously, if you're in the mood for creating content, Adobe is the place to go. And if you are going with Adobe, I would seriously consider Lottie, as they make it a lot easier to kind of play that across platforms. RRWeb is a cool open source project that will let you do sort of the same kind of coding tutorials that you see on Scrimba. It does require some config, but if interactivity is interesting, then certainly that's an option. And finally, Vectorly, we're working on a general raster to vector converter, which can take, input videos like MP4 files and transcode them to SVG and WebGL and have them place nicely with modern video architectures. Still a work in progress, but that's what we're working on. Thanks for listening to this talk on vector graphics and video, and